Today we're going to go back to it. We're doing this is pagan up here, and this is a grammar called bonsai mark, which is a subset of common mark, and this is its rendering as scanx expressions. And so we are going to be doing, yes, I feel jazzy. This is what we're going to do. It's kind of unexpected that I would get this. I was thinking I was going to get really nice for both individual error messages. And then when I realized when I combined everything together, that when I'm parsing an entire grammar, I'm just going to get one error for the whole entire grammar that's not going to drill down. And so that has caused me to rethink some of the stuff I'm doing. Time. And from there, we would solidify a pagan specification and generate a high performance parser from the same exact code. So that's the process of the life cycle of grammar development. And this is going to be a thing that's going to be more important. Agree to do something to advance the scanner, and then they return true or false about whether they advanced or not. That's it. And the reason this is the best way to do it is because you can control each stage of the process and test it as you go. Build up. And then you have another function that parses something made out of that thing plus other stuff, et cetera, et cetera. And that's hands down the easiest way to write a parser. There's not a lot of recursiveness going on. There's just a function call. That's it. And one of those ways is, we simplify and give error message for each thing. But the reason I need to break these out into functions first is because we need to deal with the idea that function references are going to be in the error output, and we need to create an index lookup of error messages for that, and we need to get those functions done first because of that. Escape, yeah. Let me, just to show you the contrast, okay? I'm going to do this as a bash script now. All right, so let's do that. I did the macro version, which if you get wrong, you're fucked and you can't fix it. Easily. Or you can just write a bash script. You can write a filter script and do like God intended. File, icon for PDF, icon for HTML. How about we get a text file? There it is. All right, so this is an RMC. This is what an RMC looks like. This is how the internet is defined. And they're all in text. And if you notice, they're very specific about their width. And that's important if you're going to do an RFC. Everybody who's anybody in Go is on this mailing list. So you can kind of lurk. It's like, it's not Reddit. Let's just put it that way. It's not Reddit. It's like real. It's like good. Everybody who's anybody is here, but you got to kind of be a fly on the wall and listen to what they say. What constitutes code coverage? Code coverage means you've written unit tests that cover the thing and that test for expected output. That's it. That's the bottom line. And whether it's C++ or Go or whatever, same thing. That's all it means. If you're going to do true code test coverage, you should have users involved and not just have it be automated, but the automated version of code coverage and by having 100% code coverage. So they'll spend an unusually large amount of time writing mock-ups and all kinds of shit that has to also be tested and constitutes tons of unnecessary complexity for testing when having just a user do the testing through some non-automated process will be better. So I'm not a fan of obsession about code coverage. I hate it when people do shit inconsistently in the standard library. JSON encoding from the Golang library is one of the biggest pieces of shit written in the entire standard library. Dangerous code inside of script tags in HTML, so we're gonna fucking unnecessarily escape all of the angle brackets and ampersands. Who the fuck's idea with that? I want to know their names. I want names. I want to know who made that decision. That was the stupidest decision ever in that library. It's like, this is so fucking ass backwards. I can't even tell you. And then I went through all of their hoops to do it the right way. I just went through all the hoops to do it the right way. And they throw an extraneous new line onto the end, completely against the standard, just so that I can get what the standard defined in the first fucking place. Just trim it off. It's not a big a deal. If it's in the standard, awesome. But why the fuck does their standard encoder with JSON.Marshall, when I call Marshall without doing all this encoder myself, why doesn't it do it the same way? Why doesn't it do it consistently? It does not. How did you do that? You got exactly to quote 16. I didn't know you could look up a specific quote. That is so cool. I learned something today. That is so cool. I learned something more from Wired WLD is knowing what you're good at. Just having an intuitive feel for what your brain tends to like to do and is good at doing. Once you kind of get dialed into what those things are, you just find things that match that. And it's hard, but you got to do it. Over time, you'll get it. 5 or 6 languages, be conversant in 5 or 6 languages that are all back in language. I pretty much named them. And in addition to that, you need to be really like expert in one of those languages that you can pull up anytime. And I would suggest that should be Go. That's my advice. Exactly what we want. You see what it did? It did them both right. All right, so our code worketh. So it doesn't have to download it. I don't have to do a go get it. It'll just grab it from my local copies. So I can make changes simultaneously until I'm ready to commit. Working on multiple packages at the same time. One of the best reasons to use Go 1.18. I need to make a whole video on that. Seriously, it's like fucking amazing.